Good morning, good afternoon, and good evening, everyone, from wherever you are joining. I hope you're all doing fine. Today, I will walk you through some of the upcoming ESS solutions for utility scale projects from Huawei. And thanks for joining my session and for listening. I would be more than happy to also get your questions after my session. I want to start by saying that there is something extraordinary happening if you look in the solar industry, actually. Energy transformation is becoming the key term. And as you know, that the appetite for solar is now everywhere. And the transition to renewables is gathering pace globally. And you could see that solar is one of the key technology that is driving this energy transformation. And you could see that there are clear targets and there's a lot of commitments from the industry, from governments, from decision makers to make the society to reach the low carbon targets. And we would see an extraordinary proposition of solar, especially in the renewable mix or in the energy mix. And this means there is a fundamental new way to think. And when solar PV technology will become the mainstream energy supply, there are a lot of things one need to consider, which are a little bit different to the way how traditional energy generation sources are functioning. As there would be a temporal topic, a temporal in the sense that depending on time, you would not have the resources on the time that you need. That means the time when you have load. And there's also a spatial topic here, as you would not have, let's say, the resources in the location that you want. So these are bringing quite a lot of challenges and at the same time opportunities when we speak about solar technologies that will become the mainstream energy transformation as I'm speaking now. You might be aware that the solar was a very young industry, I would say, and there were a lot of innovation and a lot of technology that has been accelerated in the recent years. From the module technologies to the inverter technologies to the power plant design and application side, including, let's say, a lot of connectivity and innovations through AI technologies. We see quite a lot of quick transformation that's happening here. And previously, people could think that as a very high cost industry and having a very inefficient system. But now we can be very sure that it's a very highly efficient, mature, and reliable technology. As you see that the solar is winning against various energy sources, even without subsidies. So in order to bring in more renewable solution and to converge digital technology and power electronics innovation, we have to go through certain, let's say, steps that will bring in still, that will make the PV as a mainstream energy. You might be aware that in the 90s, when there were 600 volt based technologies, and around about 2009, 2010, 1000 old system start to catch up in a lot of installation from rooftop, C&I, and also in utility scale. And when PV was basically relying on subsidies. And we saw also the transition when we brought our string inverter technology around about 2014-15. We saw that it was going into the grid parity times. And we also saw 1500 volt technology going mainstream. And now as I'm speaking, in order to continuously reduce the PV LCOE and to make sure that the PV become mainstream energy, and also to have innovation. And we looked upon through a lot of methods and measures that will categorize the technology with the existing low voltage directives, but at the same time take more out of the existing directives. And what we saw was that in order to bring a more economical, a reliable power plant, and to have energy generation running through renewables, we need to think on, in the utility scale, something completely different. And in order to do this, we went on a journey by asking questions on how to build a power plant solution, how to bring a power plant station concept that will correspond to the state of the art technology, where we will still reduce the system cost and provide high efficiency availability with the existing directives, as I said, the low voltage directives. And through our innovation and R&D team, we came to an answer that when we would make use of a bipolar architecture for transmission, as a DC transmission, we can achieve a very appreciable amount of savings in cost, and also the consumptions of energies, like consumption of resources, like metals, for example, aluminum, steel, copper, can be significantly reduced by making the power plant also be more sustainable, basically. So this also creates a momentum to build large power plants. It's able to handle modern day technology of the PV modules, large current modules or low VOC modules, and at the same time bring in new integration for grid support, and also come into the key topic that I would speak today on technologies with storage as well as grid forming methodologies for the grid. And as you see here, there is actually quite a lot of interest to have renewable energy penetration into the grid, as I said before. And when we see that large number of renewable energy will penetrate, as I said, you have the spatial problem and the temporal problem, and this brings in actually a challenge, as the inertia in the system will get weaker and get reduced. Or in other words, the system strength will decrease, basically. And as you might also know that many of the renewable resources are located in very weak areas in the grids or in pockets where there are a lot of stability issues. And with the current trend in increasing the penetration of asynchronous generation, and when we also know that the future grid is not expected to be stronger anytime, with a lot of penetration of renewables, considering a weaker situation, one needs to come up with a lot of new capabilities into the inverter technologies. And this, coupled with innovation in the inverter technologies, is able to bring, let's say, a kind of a new concept called as grid forming methods, or let's say grid forming conversion technologies. That means we have been thinking PV inverters as basically a current that is injected to the grid, anchoring on the grid voltage. But now when we start to think more as grid forming, the system is able to provide its own, let's say, voltage capabilities, and actually is able to provide a lot of ancillary services, and also participate and involve in black start when there is a need with renewables, and able to effectively work as an harmonic sync, and able to work in a very, very weak situation in the grid, and could also do microgrid islanding, and also grid tied, and able to provide better responses for the power systems, basically. And that is the necessity to think about storage. And when we try to couple the storage with our new emerging technology that I mentioned before, we are able to reach a lot of LCOE and LCOS reduction in the power plant level. And now when we would couple PV and ESS with defined algorithms, as we talked about grid forming methods, and also to bring in a lot of, let's say, capabilities to provide frequency regulation support, to bring in arbitrage. One needs to come up with the proper technologies. At the same time, one also need to think about granularity and modularity, because availability is very, very important when we speak about renewables, when it becomes mainstream. And so we would see a good combination of PV and ESS, and we would see a little bit more on the concept as a brief overview, as today I'm giving a taster on what the technology is going to be, and what are we going to bring in, as there's quite a lot of expectations in the market, as well as what are the concepts that we are able to bring in to get, let's say, the PV becoming mainstream. We have to think a little bit here also on our new concept and how does it differ from a traditional ESS solution. Our new concept is, as I said, the smart string ESS, which brings in quite a lot of technological innovations there. There is kind of, let's say, optimization done in the pack level, the battery pack, in the rack level, and also bringing in high amounts of modularities, so that there is a redundancy that could be maintained, which can bring in high amounts of availability, coupled with innovative, let's say, thermal design and climate control and climate management, is able to bring in also much efficiency in the entire system. And what is also important is the lifetime, and lifetime depends upon quite a lot of factors, like what is the depth of discharge, how the system is being cycling, and how the climate control technologies are actually implemented into the entire system for the battery. And this we can see as quite a lot of innovation coming from a very traditional concept to the next generation innovative concept, with optimizations done in the pack level, and so that it's easy for even a layman to do, let's say, troubleshooting, and also optimization done for full charging and discharging, so that the entire utilization factor is increased, and also availability is kept high through modularity, as we always have in our string inverter design. The same concept applies also in the ESS technology and the design there. So if you take a look here, a very simple overview of how the solution would look like, we would call it as the Luna 2000, our smart string ESS, and coupled with the power conversion system for the Luna 2000, which is like a bidirectional inverter here. And one could think of coupling it in the transformer side, maybe in the LV side or in the MV side, and then stepping up to the grid and going into the medium voltage, high voltage, etc. And some key important takeaways here are the extended life of the battery, and this is actually depending on various factors, and what we have considered is here on thermal design, on the climate control technologies, as I said before, and also the way the battery management system is designed, in order to, let's say, bring in the state of charge in a correct way, and also to do optimization when there is, I mean, in terms of internal resistance of each batteries, and doing cell balancing, etc., in a very proper way. And modularity here in the system will bring in a simple O&M, and so there is going to be quite a lot of savings in the O&M cost, OPEX. And also one of the important things that we brought in is, let's say, AI-aided fire risk prediction, and also bringing technologies that are very safe and reliable. So as a summary, what I wanted to share with you today, as I said, this is giving a taste of the technology that is going to come in, as you would see, something completely new with the new architecture and the design with the battery, and with the energy storage system is going to bring in certain key KPIs that are very important for your project. And these are like deep discharging, let's say, compared to a traditional system, configuration, which is going to, when you compare with a typical system, could also support augmentation of batteries, which is not always the case in terms of the centralized solution, and O&M cost reduction, so that there can be reduction in terms of number of spare parts and replacement cost and time, and as I said, could be done by even a layman, as well as bringing in high amounts of safety and reliability here. So that means AI-based detection on finding if there is any kind of internal issues, and to prevent fire risk, and to check if there is a potential short circuit fault, and also help in identifying and providing alarms through the battery management system and total energy management system, basically. So these are the key important things that we would bring with our technology. As you see here, there are some key takeaways, the concept that we are planning to have for the new architecture, and the way we wanted to introduce, or let's say integrate in the new architecture, the energy storage solutions, basically. And so saying, I would like to thank you for listening to my session, and I hope it was quite interesting for you to understand where the direction would go and what are the technologies that we would bring in. And please watch this space, and please get in touch with us. And you will, if you have more questions on our concepts and technologies, we are more than happy to share and to provide you more information on that. And please watch this space. As I said, there's quite a lot of interesting concepts and solutions that we would bring in this year. And thanks a lot for listening to my presentation. Thank you very much.